If you are taking enterprise network, you know we started yesterday the same thing. It's always good to join the classes. There's always something new here and there. Okay. Just put a rule for this class. At any moment you want to ask any question, just open the microphone and start talking. Or you can see, divide the screen so I can see your the chatting box. You can write anything at any time. I will read it with you. Okay. So if we look at our computer networking course, the one you studied, I believe many of you already took the quiz, so at least you know this one. First module was only talking about internet in general, why it's important, what we are looking at, how internet changed our lives. I can skip that part because I believe by time it will be harder to explain how internet changed our life. If your life, all of it was internet, it's hard to imagine life without it. But for the older generation like me, we lived few years without internet at all. And then we start seeing the internet, a very slow one. Later, we can see the nowadays internet much more advanced. Most of the problems we used to have with internet already solved. So, of course, we are expecting things to change more and more with the security, with the scalability, with too many other issues we will have with internet, and we always have to find solution for it. Module 2 is about how to configure a switch. For this one, we use Packet Tracer. I hope you have the Packet Tracer with you. However, I will not start with module 2 now. I will go and talk about the theoretical part. Maybe next class, if we have time, we can start with Packet Tracer. For the time being, we just talk about the theoretical part here. Module 3, if you still remember, it was about the protocols. What is a protocol? Simply, it is the language or the common language between different devices. Because if we talk together, but each of us talking in different language, we cannot understand each other. Same thing for computer. We know machine, they understand machine language, which is binary, 0 and 1. However, 0 and 1, what does it mean? For example, one computer, let me just look at, okay. I'll remove this one a little bit, okay. So if you have a computer that sending a message, which is, just give me a second, okay. Sending a message, and the message is saying 0010010. Okay, this message. Computer A sent that message throughout the internet to another device. This is PC1, okay? And the message was sent from this one to this one. Now, another device on the other side receiving that message. Okay, what does this 001001010 means? For message 1, for computer 1, maybe it's trying to say send me a picture. Or send me text, or send me the email, or send the email, send email. Okay, could be the first. It is, of course, not like that much complicated than this, but just to simplify the idea, the first 3 letters mean send, and the other digit, means email. Now, if this specific message was transferred throughout the internet, go to another device, and that device could be a printer, not even a computer. So the device will receive it and start reading it in different language. Here, this device decided that the first 5 letters means something, 5 digits. It means delete a file, for example. This is not a communication way. That's why we need protocols. Protocols means if I send you 0110, whatever binary number, you will understand it exactly the same way. Why do we have 01? Because again, this is what the machine understands. It is like we have inside our hardware, there's the electricity. It's the one which decides if there is electricity or voltage or there's nothing. So according to that, there's 0, 1, 0, 1. There's high voltage or 5 voltage, if I'm not mistaken, and 0 and so on. So in that case, a message would be sent throughout this wire. It will be like that, for example. Now, this one, how to translate it to 0, 1? This is another thing. We need to translate this signal we are getting. We send it, we mean something, the other side will should receive it with exact same understanding. So what will be done here, this is at the data link layer, which we'll talk about it very shortly. They have in the computer, there's something like clock, we call it. And this clock is like that. It's like every 1 millisecond, we will read the reading. Okay, from that reading of the signal, we will decide what is the binary number it's trying to send. So if we send this one, and let's say, okay, let's do a line. This line here, it is the 0 voltage, above that and below that. Now, depend on the algorithm or the technique they are using, this can be read differently. There are some of them, they say if it's above 0, that's a 1. If it's below 0, that's a 0. Some of them said if there's any voltage, positive or negative, that's a 1. If it's 0, that's a 0. So the thing is, if the devices don't agree upon how to read the signal, we don't have communication. There's no internet at all. Cannot. Okay. So the idea here, for example, if we decide that if it's above 0, above the line, that will make it a 1. So when we read this message, you send it as a signal and it will be received as 1. This part here also 1 because it's above 0. This one 1. Then it go here and become 0, 0, 0, 0, 0, still 0. And then here maybe it will come 1, 0, 1, and so on. Okay, so this is simply what will be happening, how we turn this signal we are getting into numbers, binary numbers. Now, the issue is the user of the computer, this human being standing here, okay, the user is a human. Human cannot understand the signal. If you are not professional, like working or studied electrical circuit or communication, this thing means nothing at all to you. And even if you study IT, this one, what does this mean? Nothing. Binary number. What does this binary number means? You cannot get it. But at the same time, remember that the human being cannot get this one, and the device, the hardware, cannot send email. Okay, the human language. That's why these protocols are very necessary, and that's why we have the different suits or different model to deal with different layers or layering of devices. So how many layers do we have for internet? How many layers? Anyone still awake? Can you tell me how many layers we have for internet?
7.
We have 7. That's under OSI model. And we have another model, which is, anyone remember the name of the other model? TCP/IP. Okay. Just to let you know, these two models are just, you can make your own model at the end. However, why we are using these two? Simply because the big companies choose to use these two models. Microsoft decided to use TCP/IP, and in 1980s, Microsoft was making the main operating system in all, maybe 90 or 80% of the operating system at that time using Microsoft Windows. So if Microsoft said that this is the model we want to use, all other companies will be forced by time to use that model. If I'm not mistaken, Apple Macintosh decided the OSI to use OSI. That's why we have it. Okay, so now when we come to study, doesn't matter. At the end, it is just a theoretical framework to make our life easy when we deal with internet. So if you go for the 7 or the 4 or the one I like, which is 5, it's my own model. Okay, it doesn't matter as far as it's doing the job of dividing the internet in logical layers, which will help us to study the internet in a better way. That's simply what we are trying to do. So now, first one, I believe most of you know the name of the first one, physical layer. And it's important also to remember that for networking people, we don't like to say long words. We can say layer 1, that's enough. I will not say physical layer. I assume that everyone talking to me as a network engineer or a network administrator, everyone know what is layer 1. I don't have to explain. So what is the physical one? This is where we see the hardware. Simply is dealing with the hardware, with the machine, with the seen things. All of them are in the physical layer. Okay, hardwares. Here in this layer, the data we have in our computer, which we want to transfer to another side of the world, it will be in a term of signal. And this signal could be either type of signal, could be either electrical pulses, like the one I showed just now. This is electrical pulses inside the wire. It will be like that. And this is how we send signal. The other option, if it's not electrical pulses, could be, if it's wireless, what it will be for wireless? Can you tell me? Of course, it will not be electrical pulses. Otherwise, the electricity will be all around the air. Okay, so how do we send the signal if we are using wireless technology? What kind of signal is that? Any idea? Okay, I will assume that you are sleepy. Okay, so that's microwave signals. Okay, microwave signal. Also, if you want to represent it, those are electromagnetic. Can we say electromagnetic? It will be translated inside the hardware as electromagnetic, but if it's going all around us, it will be microwave signal. Microwave signal also, for those who study communication, it will look like this also pulses. The difference is if we are using fiber optic, we will have light pulses. When we talk about light pulses, what do you think that means? What do we mean by light pulses? It is not like this one, a wave. It is more toward different colors of light, red, yellow. Of course, all of them are inside glass or wires made mainly from very pure glasses. So glass. So the thing is, we don't study that one. And the funny thing about all this layering, we simply don't care. As network administrators, we don't care about all these things. What do we care? Who care about this? Who's playing with the physical layer? Here, electrical engineer, they have to work here to study this, to study the details of it. Electrical engineer, maybe electronic engineers also, sometimes they have to get involved in their communication engineer. This is their job. This is their area. They will study that. Okay. Who else will be there? Electrical engineer, communication engineer. Who else? Some people who study what we call computer engineer. Computer engineers who study the hardware. Okay, who study hardwares. they need to know all these details. The rest of people, we simply just use computer. If you are a normal user of a computer, you really don't care about what's happening inside the computer, how the computer is working. If you're a network user, you simply don't care. It's just like, oh, I have a wireless connection or I have a wired one. I have to plug in the wire or just turn in the adapter for wireless. That's all what we need to know as users. And interesting part of it is not only the user. If you are a web developer working at the application layer, web or mobile developer, mobile application developer, you simply don't care about what's happening in the hardware level. That's not your area. And that's the main idea we have all these layers. Not to complicate life, actually, it's to make it much, much, much easier. Because those who did IPv1, the first internet in 1969, they were electrical engineers, but they had to do all the parts, meaning starting from the server, how the server is working. At that time, of course, the computer was the size of an entire room, a big room, okay? Now they have to know how to link it. They have to know the operating system. They have to know everything about it. Even HTTP was done by electrical engineers at that time. HTTP, URL, all these things, all these protocols, basic protocols at that time. To use them, you really need to know everything about everything. And that's, of course, nowadays is not possible. Now, this is physical layer. As we said, the signal will be in terms of signal, like that, something like that. Okay. The next layer, we call it, what do we call the next layer? Can anyone tell me? What is the next layer?
Data link.
Data link layer. Or simply what we call it, layer 2. So this is important. In this course, networking concept, this is the layer we will play with, okay? In here, mainly, we have switches. Why we have switches? Switches, they don't have the rest of the layers. Meaning, if you are dealing with a switch, it has a physical device, data link device, and that's it, nothing else. So at the switch now, we have two things. We have two main things to have. First of all, the switch will have the encoding. Encoding means a way to read this signal here, the waves, and turn it to something like 0110010, something like binary number. This is the job of the data link. At the moment you have that one, the operating system can start now dealing with this, whatever information you got. Okay, so this is one of the job at the data link layer. Another thing is to give a unique ID, a MAC address. MAC address is, we can call it sometimes physical address. This MAC address simply, it is an embedded address for every network adapter. It's embedded in the hardware. And nowadays, since we are using virtual machines, even the virtual machine, to be able to communicate with the outside world, you should have a MAC address for that virtual machine. So if you want to check the MAC address for your computer, you can try now. You can open the command prompt, just type CMD in the search, and you will get this black screen. In here, just type ipconfig, no space here, but ipconfig space/all. Now you will see all the information related to networking or to the IP and MAC address in your computer. You can see here, I have not only one. I have, let's see, what do we have? First of all, Windows has its own IP configuration because some of the services should be activated by Windows. So it doesn't have MAC address because at the end, Windows is not a network adapter or, yeah, it's not a network adapter or network interface card. Network Windows is simply an operating system. So some of the things is related to the operating system mentioned here. I have Ethernet adapter. This is the cable. I don't know if I have one. Okay, I have one here. Just give me a second. Okay, this is, you can see it. The blue cable, we see it a lot when we talk about internet. This one is called Ethernet cable. This cable simply, you need an adapter, and this is the information for the adapter to put or the plug to connect it to my computer. So the information for that one, this is the Ethernet adapter. And you can see here it's connected to iium.edu.my. And there are some information there. One of the things you can see here is physical address. Physical address, as I mentioned, is the same as MAC address. Okay, let's check the next one. I have Ethernet adapter for VirtualBox. I have VirtualBox. Why I use VirtualBox? It is Oracle VM VirtualBox. Because for security, people who study security, you need to have it in order to create a virtual machine inside your computer to avoid affecting your computer with whatever security things you are doing or attacks or whatever. Okay. Of course, we use virtual machines for much more reasons, but in general, that's virtual machine. Now, virtual machine need to connect to internet as well. Since it need to connect to internet, we should create a virtual Ethernet adapter. Not a real one, not a hardware one, but we will make it as virtual. Also, we have to assign physical address to that one. And we will assign actually much more other things, but in general, physical address is what we are talking about. If any of you having VirtualBox in your computer, do anyone having VirtualBox in your computer? Can you raise your hand if you have it? Oracle VirtualBox, okay. So for you having this VirtualBox, it means that if you check the ipconfig, again, the same command. If you check the ipconfig, type this one, you will get VirtualBox as one of the adapters in your computer. If you have more than one virtual machine in your computer using VirtualBox, you'll get 2 of them or 3, or depend on how good is your computer. Okay. Can you check the IP address, the physical address, sorry, the MAC address, physical address? Is it same as the one I have here? 0A 00 27 00 00 11. Is it the same? Those having VirtualBox. It should be the same beginning, and there is even a possibility that this 11 is also same. Why? Because it's a software-based. So this MAC address will be used inside your computer alone. So if you have more than virtual machine inside the computer, they will never have the same MAC address. But when we talk about a device to device, my hardware, the number is unique. So for my own hardware, the Ethernet here, this one is a unique one. No one else all around the world should have the same MAC address like mine. Otherwise, there will be a problem with the communication. Same thing now, if you check, I have VPN. So VPN also will create a MAC address. It's a virtual MAC address. It's not logical one, not real one. I have one for wireless LAN adapter. Of course, I'm using Wi-Fi. So I should have also a MAC address for that one. And I have one for wireless LAN, another one. Then I have Ethernet adapter VMware, because also you can check, I have VMware also in my computer, creating VMware workstation, creating some virtual machines. And that's why I get it. And if we want to see all these adapters like visualized, we can go to control panel. Okay, go to control panel. And from the control panel, you can go to network and internet, then network and sharing center, then go to change adapter setting. You will see all these we are talking about. Okay, so here for Windows, because they use a visualization a lot, they visualize everything. So you can see it like icons, and you click on them, have properties, you have some features you can change. But if you don't want to use the visualization of the Windows, everything can be can be shown here in the command prompt. So you can see I have a lot, and I believe also you will have a lot. But when we go to the lab later, you will see only one adapter, because the computer has no wireless, has no virtual machines, and so on. So now if I take this MAC address, okay, and try to understand what is that MAC address. Okay, you can see, oh, I have only one page. Why did I open one page? Just give me a second. Let me figure it out if I can open another page, or I have to move somewhere else. Okay. Right. So if I want to look at the MAC address we have, which is my MAC address, you can have another one and you check that one. What kind of numbering system do we have for this MAC address? Binary, decimal, hexadecimal, octal, which one?
Hexadecimal.
Exactly. How do you know? How do you know it's hexa? Because we have some letters, right? CB. Because for hexa, it starts 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. After 9, there's no 10. There's A, B, C, D, E, F. And then we start with 1, 0, 1, 1, and so on. Okay. So that's why how we know it's hexadecimal. Now for this one, if I want to write it in binary, because again, everything, all the numbers we are dealing with for the computer, for the devices, for the machine, they will understand it as binary. So everything we deal with, you can imagine at the end in the low level programming language, it's all 0 and 1. So everything should be converted there. And since we are dealing with machines, different kind of machines, switches, routers, we have to think like them. We have to think. If you really want to be a good networking person, or networking or communication engineers or whatever, whoever deal with these layers, you need to think like a computer. Because sometimes we get errors, we don't understand it. We don't understand why the device is confused. If you think like the device, you will understand that, oh, okay, this is a very big issue. One example, for example, if you don't know how assembly language is working, you would not know, for example, 4 divided by 0, why it is a huge, huge, huge problem for the computer. As a human being, if I get 4 over 0, what is the answer? If I try to divide by 0 in math, what do you will get? Infinity, right? You'll get infinity, which is not a big deal. Yeah, okay, it's infinity. But when we go to computer, that's like the biggest crime. The computer can, if we leave it alone, it will explode from this 4 over 0. Because how the computer is designed, if you go for the low-level language, it is very, very crazy idea to have 4 over 0. So again, if you have a binary number, to understand why we are dealing with, later when we talk about broadcasting and multicast and so on, it's always very important to remember that machine understand only zeros. So for example, 5, if I want to write it in binary, in this case, we have to represent it in 4 different binary digits. So it will be 0, 1, 0, 1. That's the 5. What about 4? What it will be?
0, 1, 0, 0.
0, 1, 0, 0. Then we have 6. It will be 0, 1, 1, 0. C, what is C? 1100. Okay. Now, let's say that I'm not good in this one and I don't want to get confused. You are always, I don't even have to mention it. If we are dealing with networking, you are allowed to bring your calculator. In my time when I studied networking, calculator was not allowed. We have to do it manually. Okay, so if I want to turn E, which is hexadecimal number, I just type E and then I would look at the value in binary. Okay, it will be 1110. So that's E, 1110. For B, it will be 1011. By time, you will get used to them, especially some numbers, we use them a lot. That's why we remember them easily. 9 will be 1001. 5 will be 0101. B again, 1011. A is 1010. Okay, so you can see this is what the machine understands. As a human being, if I want you, I ask you, please give me your MAC number, MAC address. Saying this one, it will cause a lot of errors, right? Now, if I tell you 1010101100011, you cannot even follow with me. It's very hard. So as a human beings, we cannot understand this one. MAC address written in hexadecimal is not just because we want it to be like that. It's just to make it easier. It's a number we may need to use, not the normal users, but those who are dealing with operating system. Again, those we talked about who are in data link layer, or we didn't say who's studying data link layer details. Okay, do you think communication engineers need to study data link? Communication engineer, they need to study it because these are the people who are giving us the signal and need to translate it to operating system in binary. Then the binary, when operating system receive it as a binary, can understand it. But before that, it's a signal. Electrical engineer also, they need to study this level. Electrical engineer, they need to study it. Computer engineer, also they need to study it. Who else? Here we will have operating system developers. We have compilers and interpreters. Okay, compiler developers. Who else? We will have developers. Okay, who else? In here, network people will get involved in here. And you can see all of them are professional people who somehow should understand even hardware. For example, you are not here in this class without taking ICO, Introduction to Computer Organization, to understand a little bit how computer is working. But as you want to go down layer, you really need to go to more details. Since we are network people, we'll be in layer 3. We don't have to study in details how electrical signals will be transformed from one form to another one and all these stories. Okay, so these people now, if you tell them that the hexadecimal number, we can use it for MAC address, it's not a big deal. They are professional people. It's fine. But if you take this number, let's take it, and take it up to the user. Where is the user? This user. Okay, I need to draw it. Or take it even to web or mobile application developer. Give them the MAC address. They don't know how to deal with it. It's a hard number for them. It doesn't have any meaning for them. So again, we use it because we want to understand the machine and let the machine understand us. Now, the next layer is network. Network layer, which is layer 3, this is if you study, for this course, we will use it a lot, of course, but not as much as data link layer. Okay. And if you're taking enterprise network, we will not talk about data link layer at all. Everything we will talk about in network layer. Now for network layer, here we have one important thing, which is the IP address. Okay, IP address in this layer is simply a core subject. Okay, This is what networking is building on it. It's what's making the internet possible. We even call it internet protocol. So everything about internet simply based on this network layer. So if we don't understand it, it will be an issue later. That's why we will spend a long time just to make sure everyone get what is the IP address, how it's been used, different type, and all these things. Now for network layer, who will study it? Do you think electrical engineers need to study networking? Yes or
No.
no? What do you think? No, they don't need to study. Communication engineers?
Yes.
A little bit, just basics only. So now if you go to study communication engineering in College of Engineering, they have a very simple course for networking. So communication engineering, they should have an idea about communication engineers. They should have an idea about networking, but most of their work will be layer 2 and layer 1. Okay, computer engineers, they will study it in details. Operating system people, they have to know how to do the coding for it because they have to program the sockets and so on. Compiler developer, not really. Network engineers, network admins, network, all these people dealing with networking people. Let's call them networking people, just for short. Anyone dealing with networking, of course, they will study it here. Who else? Okay, do you think the web or mobile application developer should study this one? Network layer. Yes or no? What do you think?
No.
Another one. Okay. The students who are in IT department, studying IT, BIT, they would take at the end. Do you think they have to know networking? When you took computer networking, they were with you, right? In the class, but they are not in the specialized one. So it means they need to have some idea of what is IP address. Because if you want to connect your application to the website, at least you understand what's happening with the IP. If you don't know, it will be hard to do or connect your phone, your application, your whatever, your website to the internet. So taking the introduction level should be enough for these people. Okay. Who else? I'm not sure. Maybe there are some other people should study this one, but you can see now the idea of the layering. When we make it like that, now I want to specialize in networking. So this is my field, only this one. I don't have to go and this is where I work. However, since layers are not real layering, they are just logical one, they're affected by what's below them and what's above them. That's why in networking classes, we have to talk about data link and we have to talk about the next one. What is the next one? What's the next layer?
Transport layer.
Yes, transport layer, which is layer 4. Okay, this one here, what do we have? What's the information do we have here? We have two main things, segmentation. Okay, will be done at this layer. And also we have the port number. I will talk about these things very soon. Okay, who will study this one? Actually, communication engineer, no more studying that at all. They don't need to know it. Computer engineer, they still need it. Computer engineer. Who else? Operating system developer, they have to know it. Network people, they have to know it. IT people, now they have to get more information about this layer because simply they will use port number. Definitely they will use it. They have to know what is port number. IP address, maybe you give them the IP address, they use it. They don't know the details of it. But for port number, they have to understand it well. Who else? All this web and application developer, web application or mobile application developer. So let's call that application developers. All these should study layer 4. Next layer. And here, okay, after here, IP address. How do we write the IP address? Let's go back. If I have an IP address, which numbering system I will be using for IP address? Binary, hexadecimal, decimal, octal, which one? For binary, for IP address. If I ask you what is your IP address, or we check the IP address here, cannot be binary, right? The computer will understand it as binary. But when we talk about it, you can see this is my IP address now. It is in which numbering system?
Decimal.
It is decimal, okay? Why we make it decimal? As we said, as we are going up toward the upper layers, we are coming nearer to the human being, the human here, the user. And the user, maybe I'll ask, he would call you and say, oh, the internet is not working. Then you ask him as a network administrator, what is your IP address? Can you imagine if this human is 70 years old constructor person? You tell him what is the IP address, and then he should tell you the binary number. It's impossible, okay? To get it is very hard. Even this one sometimes is hard. So you need to make it easier by using decimal, which is numbers everyone is using, okay? Just tell them, go to command prompt, write this one. What is the number you see in front of IP address? He will give you 10.111.33.222. Okay, so it's easier now, or 222, but yeah, you can use whatever, okay? Either you say it as a number or just say digit by digit. So now this IP address, this is how we read it. But the computer, again, will read it as binary. Now, to change hexadecimal to binary is different than how we change decimal to binary, because the base is different. We don't have to worry about it. You study it maybe somewhere else. I believe even in high school you study it, how to change between the numbering system, but use the calculator is enough. Now, if I have a decimal number, which is 10, just type 10, you see the binary number for 10, which is 1010. Okay. However, since we are talking about decimal number, and we need 32 bits for the decimal number, so we have to start with zeros. Okay. Because if you use only 4, what will be the maximum number you can use? If you use only 4, what is the maximum number you can do with 4 digits? Let me ask this again. What is the maximum decimal number you can have if you use, actually it's not 16 the maximum. The maximum is when all of them are 1, which is 15. That's the highest you can get. Of course, if you start from 0, 0, 0, 0 to 15, that will make it 16. Okay, also it's the right answer. So now this is how we write it. We need 8 bits in order to represent every group, or we call it octet, of the IP address. Now, 1111, if you want to do it, of course, same thing. 111. Oh, no. Okay, 3 ones. This is the binary representation of 111. Okay, copy paste, put it here. Next one, 3333. Can we do it without calculator? Can you tell me what is 33 in binary without calculator? If we have 3 zeros and a 1, then 0, 0, 0, 0. Is that 16 or that's 32? That's 16. So if I change this one to 0 and make this one 1, this is 32. Is that correct?
Yes.
Yes, 32. So I need 33. I got 33. Okay, now 222, of course, it's harder number. I will not go for waste my time doing it. Just write 222. as a decimal, you get the binary number, use it as it is. Okay. I will use it as it is. Okay. So this is the IP address. You can see this one is 32 bits. Okay. And what about the MAC address? How many bits? It will be 12 hexadecimal, each of them represented by 4 digits will give us 48 bits. Okay. So what the MAC address, actually for this course, we really need to know it, because this MAC address we will use it to generate the IP address in DHCP. In networking concept, DHCP, we will need this MAC address. So we need to understand the concept of it. Now this IP address, if you give it to a person, let's say any person, you tell them, just write command prompt, give me the IP address, they will give you this number. It's an easy number to remember, to say it even, nearer to human being. However, again, if we go to our layer, as you come nearer to the user, numbers are not a preferred things. If I tell you what is the IP address, or use the web browser to go to IIUM website, what it will be? 10.101.250, I think, .20. Let's check. Is that the IP address? Not sure. Advanced. Okay. You see, it is IIUM website. Okay. So now if I tell you to use Google, you have to know the number. To use, I don't know, any website, simply you have to know the number. It's impossible for us to remember, right? That's why when we reach application layer, as we reach to the human being, from now on, we will not talk about IP address. We have to talk about something easier for human being to understand, which is words. Okay, we use some words for human being to remember. However, how to change this IP address? When we just write 10.101.250.20, how to change this one to be this IP address? To become this one, we need some protocols to do it. Anyone can tell me what is the protocol to use to change from IP address to a domain name? What's the name of that protocol? You studied it in computer networking previously. It is application layer protocol. And it's changing IP address to URL domain name. What's the name of that one? It's called DNS, domain name service. Okay. We will talk about this one in enterprise network. No, actually, this one, we don't study it here. We have some courses by Internet Society. Inshallah, I will open one for you, which you will build a DNS server and deal with it and understand how things are done in DNS server. So that's, we don't study it here, the details of it. In general, this is DNS server. Now, transport layer, we said there's a port number. Why do we need port number? Because when your computer receives a message from a server, where it should go? Look at my web browser. How many I have? Many, many, many of them. Not only these, I have much more. You see, I have this one also. See how many are opened? One day I calculated them, they were above 80. Okay, so you can imagine now a message or a packet or a piece of data came to this computer. Where it should go? To differentiate exactly which application, we need the port number. This port number, it would tell the operating system, take this piece of data, send it to, let's say, which one? This one, number 5 or 6. Whatever, it will give port number. From the port number, it will know that this is a website called Magic School. It's AI platform for kids. Okay, so you can see here that you will never open a website, ask for a specific information, and it will go somewhere else. This picture, there's no way it will go to any other tab. It will always go to the right one. When you open IIUM website, you will not find a picture coming from another server to another place. Supposed to be in here, but it went there. This is how it's happening, using the port number to tell the operating system where exactly to take that piece of data. And if we talk about operating system language, I'm not sure how many of you still remembering operating system and what you studied there. This one, we call it process to process. So the CPU will know that whatever process data you get from outside, it has a process name or process number. This process number will go and serve another process. If that makes sense, but it's operating system thing. Let's talk about the other layer. What's the name of the other layer? Layer 5. What's in layer 5? What do we call it? Session. Okay, before we continue, we have 30 people here. How many of you still awake? Raise your hand. 18, 19, okay, 11 sleeping, okay, 10 sleeping. Okay, 9 only sleeping. That's not a bad number. Okay, so let's continue now. For this one, it's the session layer. Session layer or layer 5. Usually network people, we really don't care about session, presentation, and application layer. Layer 6. We really don't care about them. This is the mobile and web application developers. Maybe security, sometimes we have something to do here, but for networking, as simply transport layer is the last thing we need to know about. Some of the application in general, application protocols we need to know, like HTTP, HTTPS, because it will involve with the networking. But at the end, it's not really our main concern if it's not related to networking. And when we talk application, here we are not talking about the web browser I'm using. This is Microsoft Edge, okay? I'm not talking about the web browser. I'm talking about the protocol used by web browser that will make communication possible, okay? Whatever protocols related to it. So the web browser is not only about the networking and connect to internet. It's also have some aspect of the user interface and all these things, the database maybe. So we only deal with those protocols in application layer related to networking. For example, as I mentioned, DNS. We have to know how to convert this one to a binary number. Let me try to see, for example, this was. Let's try to ping this website, kamiapp.com. Let's see, what is the IP address? You can see this is the IP address for this website I'm using to write all these, whatever I'm explaining, okay? This is the IP address. So who's converting this kamiapp.com to 18.67.181.90? This is the DNS. So that's what I care about. I care about the URL. I care about the protocol. I care about DNS. This is what we care about in application layer. It's not the entire application. Entire application, web and mobile application developers will care about it. Operating system, sometimes they have to get involved in there and so on. Now for session layer, simply at the moment, let's say I open this one, let's say I will click on academic. At the moment I click on that, a session will open, send all data to the same place. So we have text, we have pictures, we have some links there. All of them will be sent in one page. And then it's done, stable. No more things to be sent here, nothing, right? So now the session is closed, meaning that we send everything related to whatever you requested from the server. That's a session. I click on centers. Now new information will come, all of them together related to the same page, to the same session. When all are transferred, the session will be closed, because if we don't close it, some bad people can use it to attack. So session layer, we need it if we talk about security. Usually we don't study anything related to it when we talk about networking. Okay, except maybe when we talk about TCP IP, TCP handshake, 3 handshake, we'll talk about it later, inshallah. So maybe something about it will be mentioned. Okay, another way of thinking about session, the current Microsoft session, we open, Microsoft Teams session, we open. I open the session. Now every data related to whatever I'm saying to this class would be inside one session. They connected the data related to each other in one place, okay, in one session. At the moment I close end meeting, the session will be closed. You cannot send anything. If you want to communicate with me using Microsoft Teams, you have to use another session, open a new session. So that's simply what is the session layer doing. We don't go and study it a lot because it's more toward how applications. For example, you ask for delivery. At the moment you click on order something, a session will start, which will include the driver, the restaurant, everything come to you. When you receive the order, the session will be closed because no more related things related to that session of ordering. So simply, that's one thing. Now for the presentation layer, it's more toward operating system, how the operating system manage the files, okay? How to present the data we are having. So if I'm having, I always give the same picture. If I go to my picture file in here and take one of the pictures I'm having, okay, this is a picture of what we call physical attack. It's one of the cybersecurity attack, okay, physical attack. So now if I'm here, this is a picture, I'm seeing a picture. How to, it's a piece of data at the end. The picture is a data. Now, how to present it, how to show it to the user, this is the presentation layer responsibility. If you look at this picture, it is JPG. It has some dimensions to show and the size. If I open it with the wrong presentation, the data will not be useful. So if I try to open it now, I choose another application, let's say Notepad. Okay, Notepad is supposed to be for text, not for images. I try to open an image with Notepad. We know that it will open. However, the way it's presenting the data is not useful for the human being. You can see here, all these are real data. It's opening the data, and it's the correct one. But how it's presenting the data is wrong. We cannot use it simply. Okay, so that's simply what the presentation layer do to find the way or to deal with the way to present the data. If the data is a video, I'm not sure if I have any video here or there, I'm not sure. I had video previously. Okay, delete it, never mind. Music, I don't have music, I know that. Okay, so in general, try to open any video, any picture with the wrong files or the wrong presentation. You will get the picture there. However, it will be cannot be used simply. Okay. Now application layer, this is, as we said, the HTTP and so on. So these are the layers. Is it clear? Any questions here? Do you have any questions? Yes? No? Everything is okay? Okay. Hopefully you are still awake. So let's talk now a little bit about our picture, the picture I just show. What will happen to it as it's going up from the application layer and go down to reach the physical layer, transfer to another side, and the other side will get it and see the picture. So let's talk about the layers again. I just call them application layer. Application layer. I don't use the presentation and session because in one model, actually, they're all combined in all of them. TCP/IP, all the session, presentation, and application, they are one layer. So I prefer just to consider it as one. Transport layer. Transport layer here. Then we have the network layer. Network layer. Then we have data link layer. And after that, we have the physical. Okay. Now, at the application layer, what do we have is our picture. The picture we just showed, that picture. Let's say the picture is a very small picture or a very big picture, doesn't matter. Let's say it is 1 megabyte, or let's say 4 megabytes. Okay, that's the size of our picture. I want to send the picture throughout the internet, maybe from the server to the client, from my peer-to-peer. You know what's the peer-to-peer? It's like no server, no client. It's just like the WhatsApp. I sent to you, you sent to me. There's no server involved here. Theoretically, okay? But in practice, they have the server. So now this is message. I want to send it throughout the internet. At the application layer, presentation, session, all these things are, yeah, it's what's happening there. However, when this here, we call it data. The picture here is a data. This is our data. We want to send it. So now we want to send. It will go to transport layer. At transport layer, two main things will happen there. First of all, this picture will be segmented into smaller pieces. Okay, smaller pieces because simply we cannot send the 4 megabyte altogether in the internet. If we do that, it will be a lot of problems. We don't have to worry about those problems, but it's just not how things will happen. We have to cut it into smaller pieces. So what do we call these pieces here? We don't call it data anymore. At the transport layer, it has another name. Anyone can tell me what is the name here?
Segmentation.
Yeah, we did segmentation and we call the piece of data here as a segment. Just segment. So in layer 4, if you are dealing with layer 4, we don't call it data anymore. We call it segment. If you deal with any layer, you have to call it in the correct name because this name has a meaning. If I say a segment of data, we will know that, first of all, it's not the entire data, it's part of it. Another thing we will know also that there is some extra, we call it header, added to that segment for each of them. We will add some more information. Sometimes we call it encapsulation, which means you put the piece of data inside an envelope, add some information. What is the information we add here? I mentioned it before. It is the port number. Not only port number, also we have to put a sequence number. Sequence number. Why do you think sequence number would be important? When you cut something, you need to put some labels so later you can reassemble that thing, right? So same thing here. You cut the picture or the data into pieces. Now you need to know this is number 1, this is number 2. When you get to the other side, you collect it all, like the puzzle pieces, and put them together in the same order. Otherwise, there will be a problem. Now, if I go back to my picture, okay, I will make a copy of it. I don't want to lose it. Okay, this is a copy of my picture and open it as Notepad. From here, simply, let's say after you send it, this piece will come after the other piece. Just the order is different. Save it. Try to open the picture. The whole picture is corrupted. Okay, so that's the idea why we need to do sequencing. When we get the data later, we should be assemble them in the same sequence or order it was at the beginning. Port number, as we mentioned, we need a port number to know exactly this picture should go to this tab, not to this one. At least we will know the operating system will know where to send it exactly. So that's the port number. Now, after that, all these things, by the way, happening, and we don't realize if we are just users of the internet. But at the moment you became involved in programming and networking, assembly language, communication engineers, and so on, things will become more interesting, at least for me. I prefer to know how things are working more than just using them. Now, every piece of segment will move to the network layer, every piece of them. Let's take the first one, for example, here. New thing will happen here. We will take that piece and add an extra information. Okay, so this is our piece of data, okay, or the segment we got. Now we don't call it anymore segment. What do we call it here? In this layer, what do we call it? Yeah, we call it packet. So at network layer, we say packet, and I just have to give you this warning because my master PhD, both of them, they were in network layers. Many times I find myself saying packet when I'm talking about layer 2. It's a mistake, okay? Packet means we are talking about layer 3. It's just because I used it a lot for many years. By mistake, I will use it as a default terms. So at network layer, we call it packet. And these packets are simply having new piece of information. What is that piece? What do we put here? The source IP address and the destination IP address. 2 IP addresses will be added here. Okay. Of course, for this purple one, this is the previous port number and sequence number. We took them from the transport layer, put new information, put everything inside an envelope, write the IP address in there. What is the source and IP address? Simply, I'm going from Gomba to KLCC. That's the last destination. Which way I will use doesn't matter. Which medium I will use doesn't matter. Am I going by helicopter, by motorbike, walking? That's not our story. At network layer, I'm going from IIUM to KLCC. That's all what's matter at network layer. As we go down to the next layer, which is data link layer, now we have the story will be a little bit different. What do we call the data, the piece of data here? What's the data unit here? After packet, here we call it frame. Okay, so now if you are at frame, why we call it a frame? Simply because interesting thing will happen here. We will not add only at the beginning. We will add also some information at the end. Okay, so we will add here. What will be added here at the beginning? Add the physical address. What is the physical address? It has another name. What's the other name of physical address? MAC address, exactly. So here we'll add the MAC address. So IP address was added by the previous. I cannot do it very precise. Okay, let's say this is the IP address. Now, okay, we need to add also the port number was purple, right? Okay, so you can see now from the colors we are having what was added at which layer. Okay. Why we call it frame? Because for the first time we put some information at the beginning, some information at the end. At the beginning, we put MAC address. So here we have the source MAC address and the destination MAC address. Okay. Now, what is the MAC address? We said here I go from Gomba to KLCC. Here, no, we need to know. I'm at KICT now. What is the next step? Where to go? If I want to go to KLCC, what will be the first destination I have to go in order to reach KLCC at the end? From KICT, where should I go? What do you think? I go to IIUM Gateway, right? If I don't go to the gateway, I will never leave IIUM. Then when I'm at the gateway, IIUM Gateway, then I have to look either to the right or to the left. I have to decide where to go. So if you want better example, from Gomba station, you want to go to KLCC. So IP address will be source Gomba station, destination KLCC station. But if we want to talk about MAC address, Gomba station cannot jump directly to KLCC. From Gomba, you go to Tamamilati. From Tamamilati, you will go to Wangsamaju. From Wangsamaju, you go to Srirampai, and then I don't know the rest. Okay, so simply it is like the next step. This is the MAC address. That's why here we talk about the switch, because all the time your computer will be connected to the switch or router. So all the time the MAC address is talking about who's next. I'm talking to whom? Who's the next device? Okay, so when we are here at the data link layer, as we said, there's something called encoding also. Encoding meaning that we change this one. Now it is 0110 in the computer. Now I have to change it to electrical pulses so I can send it throughout the, I don't know how to draw it. I always start good, but then it will go bad. Okay. Okay, so this one, I have to find electrical or the media I will use, because now if you talk, I want to go to KLCC, I will go to IIUM Gateway. Here at physical layer, you start asking, what is the transportation method? Am I using wireless? Am I using wired? Am I using fiber optic? Am I using a motorbike, a helicopter? How I will go to KLCC? This is the physical layer. Okay, so that's simply all what we need to know about the protocols. And if I go back to our Net Academy, signed out, sorry, just give me a second to go back. You will find now that I covered module 1, module 3, 4, 5, maybe we will go to it later. Next class, we will go to it because there's a game I like to play it. I don't want to waste that chance of playing a game. Just give me a second. Okay, here we are. Okay, I always hate this new update to the website. So if we are at introduction to computer networking, okay, to networking. Now we finish module 1, module 3, 4, 5. We will come back to it later. 6 is done. 7, I have a small thing to mention next class, and inshallah next class we will go for network layer. I know I'm going fast. However, whatever you need to know about networking, somehow I gave you an idea about. The simulation, which is in module 2, we will talk about it maybe next class, inshallah. Any questions? Everything clear? Is everything okay? Hopefully you are still awake. Class is done, okay? That's all for my side. If you have any question, feel free to ask in the chat box, open the microphone. You can leave. I will stay here maybe half a minute if anyone have any question want to ask. Or of course, don't forget the attendance at Taaleem. You have to put the attendance. And if you have a question also, you can put in the WhatsApp group. Thank you very much and Assalamu alaikum.
Thank you, madam.
You're welcome.
Madam,
Yes, brother. Okay.
I have a question.
Yes, sure.
Actually, before this semester, during the holiday, I made some research or I do some study about the networking, about the networking study. starts from what is
Okay.
networking, and then it's like I do a bit revision, and then I watch some YouTube channel that talks about the networking, especially from the cybersecurity experts. And then most of them, they said that the things that make them hard to study is networking. And I was like, oh, okay. It's like, oh,
Okay.
made me
Okay.
surprised.
If you want my opinion, to be
Yes.
cybersecurity, or good in cybersecurity, you really need to know a network. You have to come from network background, then go to cybersecurity. That's what will make you very good in cybersecurity. Right?
Oh, so
Have you ever read this one?
no, this so that's my confusion. Is it the networking is the really main route for me to go through the cybersecurity study, or is there any other path? That is my question.
Okay. Okay, brother. So the thing, because I met many cybersecurity professionals and they are working in very, very big companies for cybersecurity. Those who are like the expert ones, who are working like 30 years in cybersecurity, most of them, they came from networking background, and they said that understanding network is the best way to understand what's happening, because at the end, the attack will happen through the network. So understanding networking is a very, very essential thing for actually even IT people, because if you don't understand it, you get an attack, you don't know what happened. However, network is not the only thing. You have to study much more things. Like after networking, you have to be really good in operating system, really, really good in operating system. As you are good in operating system, you can do attacks, better attack, let's say. Okay. You need to know about pen testing. You need to know about, cybersecurity subjects in general. You need to know programming if you want to be a good cybersecurity professional, okay? So it is not only about networking, but network is one of the main things you really have to understand very clearly. As you go more deeper in network, okay, some people, for example, if you go only for network security, not for cyber security in general, network security is a very, very huge topic. Now, we talk about network security for layer 3 and 2. If you can prevent the attacks at that level, you understand it well, you understand how the machine is working, it will be easier for you later not to let the attack go to the application layer, which what you study in the subject network security. Network security course now, you don't study layer 3 and 2, you study layer 4 and above, right? Here in this course, we try to cover some topics in network security, but they are not all. In general, cybersecurity is a very wide and interesting topic. So yeah, I encourage you to go there, but network should be something you really understand. Maybe you don't want to take all the networking courses. You want to take maybe this course, and then you say, that's it, enough. I want to go for other subjects. It's okay also. As far as you feel that, okay, you got the concept, it's enough. Anytime you can come back to network and study whatever left. Not only that, network is improving very fast. So you have to be updated all the time. And this is what remind me about the project. I forgot to give you the project, sorry. I'll try to. Okay, I'm sorry. I will upload it today, inshallah, to iTalim, and then I'll let you know about it in WhatsApp. So yeah, the thing is, not for cybersecurity, you have to study all time. All time you have to be updated about what's new in network, what's new in cloud, what's new in IoT, what's new in this and that and that and that, which is a very interesting topic for some people and it's very stressful for other people. Okay. If you're a person who likes to learn something new all the time, cybersecurity and networking will be a good field to go to. I hope I answered that question.
Okay, madam. So
Okay.
from there, I want to ask a second. Is it okay, madam? Sorry, madam, because
Yeah, sure.
I'm a bit
For the
curious.
rest of you, if you want to leave, it's fine. If you have other classes, okay, we have discussion here, me and the brother. Until 10, I have another class. Okay, brother? Okay.
So I would like to do some certificate courses, and
Okay.
make research in the Coursera, in the Cisco, especially the Cisco. But yeah, when we talk about the payment, right, the money that we should buy, it feels like I think I would love to learn the certificate in the Cisco because I like networking actually, but because of the cost, and then the time that I want to manage to study the certificate, maybe I need some, I don't know, maybe during the internship, is it still reasonable for me to get the certificate or still?
Okay.
Is it,
Okay, brother. Actually, if you ask me about my students, most of them, they do it before the internship, the certification exam. Because when we are studying the 3 networking courses in KICT, you are preparing, the theoretical part is there. You need to do some reading, of course, by yourself, and then you can go to the certification, even before the internship. It's possible. However, you don't have to stress yourself out now. Okay, it's good to plan, but things can go slowly. Okay, this course, make sure that you read all the slides. It's not like only just to pass the exam. Make sure that you understand all the packet tracer. Then when you go to study for the certification, it would take a few days from you, maybe 1 week or 2. If you are studied to learn, not to get the good mark at the end. So yeah, since you are in this course, make sure that this course is completely understood. For time management also, you are studying for the course and the certification at the same time. So just make sure that you manage your time, that you read everything in Net Academy website. Understand it. You have a chance now to ask a question to your lecturer, right? So ask the question. Don't stay quiet. If something is not clear, you can clarify it. If one packet tracer exercise is not easy for you to do, ask your lecturer. So you have a chance now to do it fast. For me personally, I took the certification without any classes. I do it self-paced, meaning that I just get enrolled in the course, I study by myself, and then I go and get the exam. This is how I prefer it, and this is how my time allow me. Okay. So until now, I like to get certificates. I like to learn more. Opportunities are a lot. So you have to, first of all, okay, I'm telling you, now you can get tens of certificates right now. But if you think about the priority, since you are taking network course, this is your time to focus on network. Maybe you are taking network security, learn everything in that course. You go for cryptography, study everything about cryptography, understand it well. So later when we go, it doesn't make sense that now you focus on, let's say, Coursera course while you are neglecting Cisco course. See, so this is how it will help you to do the certification even faster, and it will manage your time. It's just priority. What should go first? Okay. So maybe we can discuss this later. I have to open the class for the other section, but it's very interesting topic to go for cybersecurity. You have a lot of chances. Even in KICT, we can discuss that later, inshallah. KICT, you have a lot of opportunity for you to get certifications. Maybe some of them are not starting this semester, maybe middle of this semester. But just today, I got the enrollment link for encryption course in Internet Society. So you can enroll. I will put it in WhatsApp after a while, after my class. Okay, so you can join them. You see in encryption and cryptography in different perspective for Internet Society. So for me, even if I take the certificate, when I get a chance to renew that certificate, I would take it again. So many of the certificates like CyberOps, I took it twice because I got the chance. So whenever the chance is there, I just take it. However, I have to make sure I have other responsibilities. For you, your study. For me, registration, waiting outside. Okay, so we talk about this later, inshallah. We have to stop here. If we need more discussion, of course, we can discuss, even if you want to meet physically, but not this week, not the next week. We have registration now, and it's the priority for me now. Okay, brother?
okay, thank you, madam.
Okay, you're
Assalamualaikum.
welcome. Alaikum assalam.